Hello everyone, I am Rohan and today I am going to present a presentation on ultrasonic sound and Arduino distance indicator, and it is a project for ICT workshop subject and it was guided by Professor D.D. Zala. Now when we hear about ultrasonic sound we first think that what is sound? So, vibrations that travel through air or another medium and can be heard by a person is called sound. So, what does this sentence mean? So, let me explain. Vibrations that travel through air or another medium. A medium means a mode of transport or a way, a path for the air to transport itself is called a medium. So air is a medium, water can be a medium, oil can be a medium. So vibrations that travel through air or another medium and can be heard is called a sound. Now, for example, let's take a look at this image here. So we can see the speaker in the middle of the image, and what the speaker is doing is that it is transmitting sound. Now, we can see the air molecules, the blue dots around the speaker. So when the speaker is transmitting sound, we can see that the air molecules are going away from it. We can say that it is almost vibrating and it is going further away, taking the sound with it. So we can see it as a good example. Now, let's see a video on how sound works, how the sound is transmitting. This video will show you how the sound looks when it is being transmitted and what is the sound of different objects like sound of a clap, a book being dropped, and how can you see the sound, and it is a basic simple experiment.
I'm going to show you the sound of a clap. And I don't mean some digital depiction of a clap. I mean that when this man's hands come together, you're going to see something that is normally invisible. You're going to see the actual sound wave leaving his hands and traveling outward at 761 miles per hour, the speed of sound. And here it is again. How is this possible? Well, I'll start the explanation not with sound, but with the heat from a lighter. There's a puff of butane, sparks fly, and the fuel ignites. But that shape billowing up from the flame isn't smoke. That's normal air that has been expanded by heat. We're able to see the density change thanks to a technique called Schlieren flow visualization. Here's how it works. You start off with a light shining through a single slit. If you reflect that light off a parabolic mirror, all the rays become parallel, and then you can use another parabolic mirror to refocus the light down to a single focal point, and then in through the lens of a camera to make a picture. Now here's the trick. You place some sort of barrier right at the focal point. Now you add something that will distort the air, like a candle. The candle will block light rays, making a silhouette, and the flame will make light. But rising heat will change the density of the air above the lighter, and that will bend the light rays. The bent light ray won't pass through the focal point. It will be blocked by the barrier, and the picture will be darker. This technique can be used to see anything that distorts the air, the heat from a hair straightener, for example. Even the heat coming off a human hand. Epidemiologists use it to study sneezes and coughs. Engineers use it to study aerodynamic flow. And sound, well, that's just another change in air density, a traveling compression wave. So Schlieren visualization, along with a high-speed camera, can be used to see it as well. Here's a book landing on a table. The end of a towel being snapped. A firecracker. An AK-47. And of course, a clap.
So now we have seen how the sound gets transmitted, and we have seen the different types of sound, and we have seen this video and how can we see sound. Now first we will look at the types of sound. So there are basically three types of sounds, which are infrasonic, sonic and ultrasonic. Now the infrasonic rays has a limit of which is less than 20 Hz. The sonic waves has the limit of 20 to 20,000 Hz, and the ultrasonic waves have a limit of about 20,000 Hz. Now, for example, if we see the infrasonic rays, elephants use infrasonic sounds to interact with herds hundreds of kilometers away, so it can transmit itself for a long distance. Also, other than elephants, whales also use this technique to communicate with each other in the water. Now, the human hear capability, what humans can actually hear, it comes between 20 to 20,000 hertz. Humans can't hear below 20 hertz, and humans can't hear above 20,000 hertz. Dogs, bats are able to hear high frequency sounds, which are the ultrasonic sounds. Now, you might have wondered, if when you whistle and call a dog, how does the dog hear it when you even can't hear the sound of the whistle? It is because the whistle is transmitting ultrasonic waves, and only the dog can hear the ultrasonic waves which is transmitted. Now, we have seen what is an ultrasonic sound, and let's see what is an ultrasonic sensor.
Ultrasonic sensors transmit sound, which is reflected by objects that move past them. They are particularly well suited for demanding objects like flat, shiny, and transparent objects, independent of form, color, and structure. But our sensors are capable of more. Using a reflector, objects are recorded independent of orientation. Even sound-absorbing objects like sponges are recognized without difficulties. Even precise diametric detection is possible with ultrasonic sensors.
Now, as you have seen, this ultrasonic sensor is using a transmitter and a reflector. Now, I want you to remember two terms for the further slide, which is transmitter and receiver. So, we will see how it works and how it does. And reflector is basically a device which is reflecting the ultrasonic wave or the sound wave in the ultrasonic sensor. Now, Arduino-based ultrasonic distance indicator. So we have seen what is ultrasonic sound, and what we have seen what is a distance indicator. So now let's see what is an Arduino based distance indicator. So Arduino based distance indicator uses a sensor which is the HCSR04, and it is like using a sonar. You might have heard the term sonar in different movies or in real life. Like sonar is similar to radar. It is a form of wave that is transmitted, and when it reflects back, it gives the distance or the shape of the object in front of it. Now it is having a frequency of 40 kilohertz to 40,000 hertz. Now let's see what is an Arduino. So Arduino is a brain of thousands of projects, and it is an open source electronic platform and easy to use hardware, and it is quite cheap, so that is why people use it most of the time in many of the electrical commodities or electrical devices. It uses a code, and you have to code and put your demand or what you need the Arduino to do in the code, and hence you can also add the different types of attachments to it and then form a circuit. Now, I am just explaining the transmitter and receiver, which I told you to remember in the video. So here we can see the image of a sensor. So we can see the first wave which is transmitted. That sensor is called the transmitter, and the second through which it is received is called the receiver. So this sensor is the transmitter, this is the receiver, and you can see that it is transmitting, it is getting reflected from the object, and it is getting received by the receiver, so it can hence show how much direction or how much distance it is between each of these objects by the sound waves or the nature of the sound wave. Now, we had made a project on the distance indicator. Now in this video you may see a different thing, which is the servo. A servo is nothing but a motor which shows or indicates the distance, at how much distance the object is. So this is the sensor, this is the Arduino, a breadboard, and all these are jumper wires. This is the servo, and this is the object which we will be moving to and fro from the sensor. So in this video you will see that when this object moves away from the sensor, the servo, it will show the change in the distance. So let's see the video. So as you can see, now when the device is moving, you can see clearly that the servo, the motor, it is showing signs of moving. It is showing signs that the object is moving further away. So now it's at 25, so it is at its limit. So the limit of a motor is not dependent, it is on the motor, and you can get different kinds of limits on different kind of motors. So this is the basic Arduino distance servo indicator. Now if you have any doubts, you can contact me personally. Thank you for listening to me. This was Rohan Roy. Thank you.